Hi, today we're going to focus on series circuits, their properties, and a little bit on the Ohm's law as well. So here I've drawn a very simple series circuit consisting of a battery and three different resistors. And even though all of those resistors they have different values, the current in that circuit is going to stay the same. So let's discuss current and resistance first. To calculate a total resistance in that series circuit, we simply have to add up all its resistors. In that case, it's going to be 240 ohms. Now, to work out the current using the Ohm's law, current equals voltage divided by resistance. In this case, we divide in 12 by 240, and it's gonna give us 0.05 ampere. Another way to say it is 50 milliampere, because 500ths of something is the same thing as 50 thousandths of something. So we can tell that the current in that circuit is going to be 50 milliampere. So why is that? The current stays the same in this circuit even though it consists of different resistors. Well, to understand that, let's step back for a moment and take a look at some hydraulics examples. Let's say we have three different pipes here. These pipes are able to transfer a different amount of water within a fixed amount of time because they're all different. So in this case, the biggest pipe would represent the smallest resistor in electrical circuit, and the narrowest pipe will represent the greatest resistor. And this is because the narrowest pipe creates more resistance for water to flow, so does the greater resistance in the electrical circuit. It creates more resistance for electrical current to flow. But what happens when all these pipe sections are connected together in series? It will simply equalize the fluid flow, and now a new pipe will transfer some fixed amount of water even though it consists of all these different sections. And the same true is for our electrical circuit. All these different resistors, they will result in some constant and same current flowing through the whole circuit. Alright, so now let's talk about voltage. The voltage in series circuits is not gonna behave same like current does. The voltage drop is not always gonna be the same across all resistors. The voltage across a given resistor depends on the value of that resistor. It's directly proportional to its resistance. Let me explain what I mean by that. On this example here, we have a circuit comprised of a 10-volt battery and two resistors, 7 ohms each. Because these resistors are symmetrical, the voltage drops are also going to be symmetrical, 5 and 5 volts in this case. This is probably the easiest example I could find, so let's do a few more. Almost the same scenario, but there are two different resistors right now, 40 and 20 ohms respectively. As we already know, the voltage across resistors is directly proportional to the measure of that resistor. And because resistor A is twice as big as resistor B, the voltage drop across that resistor is also going to be 2 times than that of resistor B, 8 and 4 volts respectively. But there's another way to tackle that problem, because this example is also a little bit oversimplified. Next time we may be less lucky and we will have to deal with more complicated numbers. So let's do it the right way. And the correct way to do it would be to figure out the voltage drop across 1 ohm of resistance. We know that the overall voltage drop across the whole circuit is the same as the voltage of the power source. The total resistance of that circuit is 60 ohms, and to figure out the voltage drop across one single ohm, we have to divide 12 by 60, and it's going to give us 0.2 volts. So the voltage of a single ohm is 0.2 volts. And all what's left is to multiply that number by the value of our resistors. 0.2 multiplied by 20 is going to give us 4, and 0.2 multiplied by 40 is going to give us 8 volts. And if we add 8 and 4, it's going to give us 12. Same number we have at our power source. So it looks like we got it right this time.